My name is Mike Granatowski. I'm the National Manager for Architectural and Commercial Projects for MAPE. My role with the company is I work with national accounts. I work with the major architectural firms across the country, doing specifications, doing presentations, talking to them. My background in the industry, I started in the tile industry in '72, coming out of college. And I started out working in the field, learning to install. So some of the things that we talk about this presentation today, and I bring up some of the ancient history to some of you, done it, been there, been involved with it. Worked my way through sales and then on into working with the architectural community for quite a few years. We're going to be talking today on the challenges of installing large format porcelain tile. But before we begin, I'm supposed to read this so that we're all on the same page together here. Make sure your electronic devices are turned off. We're all big people. We know how to do that. We do ask you to fill out the evaluation form. It's very helpful to us in knowing if what I'm presenting had any merit, where we want to go with these presentations in the future. And then return the form to the monitor as you leave. If you're looking for continuing education credits, there are sign-in sheets and self-reporting forms available outside. Audio recordings of the conference with synchronized PowerPoint presentations are available for purchase at the Fleetwood sales desk. And then stop by the event bookstore brought to you by the Marble Institute of America to purchase the latest industry resources and books. And then we hope that you enjoy this session and have a great experience at the show. We hope to see you at the International Surface event in Miami in October. Okay, so we've got that part out of the way, and we'll get into beginning on this. So to get an understanding of my audience, just by a show of hands, how many are architecture designers? Okay. How many of you are tile contractors? All right. How many of you are distributors, retailers? All right, good mix. Okay, so we're going to be hitting home a lot, making, I hope, a lot of sense to the installers. And as we go through this presentation, please, if you got questions or you're not sure of something, ask. A dialogue is a lot better. We all learn from a dialogue a lot more so than we learn from a monologue. So we're going to get into the challenges of installing large format porcelain tile. This is an AIA registered presentation, and as such, it's a non-proprietary presentation. I won't be talking about any specific products, but rather products in general and how they relate to the industry. Afterwards, if you have questions, feel free to come up and see me, and we can talk about anything else at that point. And then also, if you have questions regarding this presentation, by all means, please ask them as we're doing it. If it's something about other types of installation or questions, we can talk about that afterwards. I'd be glad to meet and greet and talk with any of you on it. Let's see, this is supposed to work for me. Okay. We have a number of objectives in looking at this presentation and what we hope to accomplish here. As a participant, you're going to learn about the calibration specifications that are followed when manufacturing porcelain tile. What does it mean to be calibrated? How does that affect the overall size of the tile, the layout, the installation of the tile, following calibrations? We're going to understand how the quality, the variety of sizes, and intended use of porcelain tile can affect the installation method. So that as we get into larger and larger tiles or different makeups of the tiles, what are we specifying? What are we using to doing that installation to making sure we're getting a proper installation? We want to discuss the importance of surface preparation. As the size of the tile increases, the surface prep is very critical. Surface prep, I liken it to cooking. I enjoy cooking. Some people say I'm a pretty darn good cook. And the whole secret of cooking is having your preparation done in advance. Your ingredients chopped up, everything you know where they're going to be, everything ready to go, so when you start mixing it together, you're not in a panic. Similarly with surface prep in tile installation. If you're not taking a look at your surface prep before you get started, and all of a sudden you got thin set or epoxy open and products ready to smear, and you find out you got a problem with the surface, it's too late. you're going to end up having an issue. So surface preparation is critical, and we're going to be talking a little bit about that because it's an important factor as we look at installing these tiles, and especially as we start getting into the larger and larger size of the tiles. We want to understand how that both the grout joint size and the type of mortar used can affect the performance of a large format porcelain tile installation. Just calling out or seeing a specification that says ANSI 118.4. Everybody knows what ANSI at 118.4 is. Polymer modified Portland cement mortar. Not thin set, Portland cement mortar. Boy, that covers the gamut of things. There's so many things out there that have polymers in it. But when to use them? Where do you use them? Which ones should you be using? We're going to be discussing as we go through this, not to make you an expert on the thin sets or the mortars, but rather to make you thinking that as I run into different challenges, maybe I should be looking at what mortar I'm using. Maybe this isn't the best mortar to be using for this particular application. And then we're also going to look at how the effects of curvature, thermal movement, deformability, and the use of expansion joints can influence your installation. So we're going to be looking at a number of things that will have a major impact on this installation and getting it done correct. Copyrighted materials, however, if you want a copy of this afterwards, just ask me and be glad to give it to you. So, before the installing of the tiles, tiles can arrive, the installers have to be aware of the fact that tiles can arrive on the project that may have warp issues, even before you install them. An 18 by 18 size tile, how big is that really? 17 and 5/8, 17 and 3/4, 17 and 7/8. All different ranges of tile. We're selling it as a nominal 18 by 18. We're selling the grout joint in a sense. So that when we take a look at these different sizes and somebody says it's an 18 by 18 or a 24 by 24 or some other size, what are we actually working with? And then as we start laying that out, how is that going to affect the overall grout joint size? If the designer has told you, oh my gosh, I want to use this tile and I want an 1/8 of an inch grout joint, and if the sizing isn't lining up on that, you're not going to be able to run the installation with an 1/8 of an inch joint. We don't want to open it up to a 1/2 inch joint by no means, but we got to figure out what, with the size of that tile, where we can address the size of the grout joint. Tile manufacturers produce a number of calibrations for the same tile. And in other words, there's a range of tile in there. If you take a look at a box of tile, no matter who you get it from, it has the color, it has the production date, and it'll have a calibration number on it. It's very critical that you look at that and see how many calibrations are on this job. Did I get it all the same calibration? Because if not, your layout and your planning is really going to change. It's you start into an atrium, for example, an open-air atrium, and you start in one area and you've snapped your lines or you've lasered it out and you know how you're going to come around and you start installing tile and all of a sudden it switches to a different calibration. Whoa, you're going to come around and the joints are not going to line up. You're going to be off. So it's really critical to look at that in advance. The helper on the job, the first thing he should be doing as you're unboxing the tile, do we have different calibrations, separating it, and if there's going to be a problem, addressing that before you get into the installation. Calibrations, I said, are indicated at the outset of the project. The tiles, if you're asking for a particular calibration or a particular size and making sure you're getting it, you're going to have as uniform of a tile as possible. As I said, if you're not paying attention to the calibrations, and I've seen this happen on many occasions, all of a sudden the accumulative effect of how this tile may be growing or closing up as you come around to finish off an installation, the grout joint is completely off and you've got a problem. And nobody's going to throw in a Dutchman or something to make it look good. So there's some other things that we have to take a look at in large porcelain tiles. And just for a moment here, let's jump back one thing here. When we say large format tile, what are we referring to? How large is large format? Anybody know? Yes, sir. That's correct. So any tile that has a dimension greater than 15 inches is considered large format. TCNA is the one who came up with that standard. When I started installing tile, 6x6 quarry, 4 1/4, a little bit of 6x6. All of a sudden we saw some 8x8 tiles being brought in from Italy. Then we started seeing 12x12, ooh, getting big. Now, I mean, if you buy a home and you see a home, 24x24 is kind of the norm in a home anymore. And we've been involved with projects now, panels of porcelain tile, 4 foot by 10 foot panels. So we're talking a large format and how this all affects this. So the thing to keep in mind is when we say large format, by definition, that's anything over 15 inches on one dimension. Okay? One of the other things we have to take a look at in some of these large format porcelain tiles is some of the new techniques in manufacturing. What we're seeing is that the technology has evolved where they're taking a layer of marble granite, and they'll cut that down to very, very thin sheet, and they'll fuse it onto the back of or onto the face of a porcelain body. And the purpose of doing that is ecologically friendly. They're not harvesting as much stone out of a mountain to create as much square footage, so you can get more square footage out of a block as you cut it thinner and thinner. Fusing it on there, the porcelain bodies a lot of times are recycled material, so it has a very good ecological story to it, saving environmental friendly and such. You get the benefits and the beauty of a natural stone and the benefits of a porcelain. However, I want you to be careful on this. By definition, what is porcelain tile? Anybody on that? Simplest definition of a porcelain tile is a tile that has less than 0.5% of absorption. So what does that mean? That means what they'll do with a piece of tile that's being classified porcelain is they'll take it, they'll soak it in water, they'll weigh it, back up, they'll weigh it first. They'll soak it in water for 24 hours, they'll pat it dry, weigh it again. The tile cannot have gained more than 0.5% of its original weight, or it's not porcelain. It can be porcelain-like, it can be a vitreous, a semi-vitreous, a faience, a wall tile. A lot of other definitions, a quarry, a paver, all have different absorption rates. To be true porcelain has to be at less than 0.5% of absorption. Now the reason I mention this is that we're seeing a lot of products coming in from all over the world. Now the Italians have been really great about making some great porcelain tiles. We're starting to see some great things made here in the States. As we go into the Far East, we're starting to see some things. They have the capabilities of making porcelain, but they have capabilities of knocking off a lot of things. And what you're getting a lot of times, if you read the fine print, it's porcelain-like. It is not porcelain. An example, there's a job right here in Las Vegas City Center, the Vidra Tower, if anybody is knowing where that is at. When that job was done, the bathroom, guest rooms there, it was a marble fused onto a porcelain-bodied tile. They put the tile up over a waterproof membrane and installed everything, and before any shower was ever turned on, the tile started popping off the wall. And of course it was problem with the mortars, problem with the installation, all of these things. And when they looked at it and found out what it was, that this porcelain body was actually absorbing water, warping, and were causing the marble to warp, and it was pulling it off the tile, off the wall. Well, when they ran the tests and they found out it was porcelain-like, it had an absorption rate of almost 24%, more than a regular white-bodied tile. So there was their problem. Everything came down, redid it, a whole other story. So when the purpose of mentioning that is that when you see these tiles coming across your desk, either as an architect, as a distributor, as the contractor, being asked to install it, and you're thinking, oh, porcelain, these are the products I've used. Make sure what you're getting into, so you end up getting the right materials, you're using the right products to properly install that. The other thing with these fused tiles, they're very cost effective, less than natural stone, and typically you'll see the specification called out, install with ANSI 118.4 Portland cement mortar. Or if it is moisture sensitive, if you find out that the stone is moisture sensitive, you may be using an epoxy mortar. We take a look at these tiles now, and we look at the large format, and what do all the designers want with a large format? They butt joint. They don't want to see the grout joints. You know, isn't that amazing? Grout is about 5% of the cost of the job and about 95% of the problems. So it's let's get rid of it. Let's try to butt joint the tiles. Butt jointing. Can you do it? Can you push the tiles up tight against one another? Sure you can. I've seen it done in Europe. The thing is, and it's done quite a bit in Europe, the thing is they'll accept the fact that the joints are stair-step, that nothing lines up. You look down a long row and you'll see it waving. They go, that's the way it's supposed to be, no problem. You do that on an installation here, a long run, and the owner comes in and sees this, they're having you ripping it out. And when you go to butt joint, you're looking for those kind of problems. So you're looking at opening it up a little bit, a 1/16 of an inch joint minimum. So it has a very low visual impact. It has a more uninterrupted look on the floor with less visibility of grout lines. And of course, as we eliminate grout, what do? We eliminate a lot of the cleaning problems that are associated with grout. The disadvantages: there's a greater risk greater risk in installation, since the tiled surface is more rigid and considerable to stress, so that if they're too close together, butting right up against another, you can have a rubbing of it and actually chipping the surfaces. Stress can pose an integrity to the entire installation system. And then every small difference between tiles, even within the tolerances, is going to be accentuated if you got everything really tight. So if all of a sudden it's getting a little more tight or opening up a little bit, it seems to be more accentuated. Grout hides a multitude of sins in the sizing of tile. We all know that. Opening up the joints, it hides and allows you to get away from a lot of things. But the bottom line is that the industry, the demands on the industry are to go into these real tight installations, tight joint installations. Rectified or non-rectified. Do we know how they come about with these rectified tiles? What we're looking at there. It's not wrecked, it's rectified. So in the manufacturing process, what they'll do is that they know that the tile has, because of firing, it'll have shrunk, it'll be a different sizing. So what they'll come in and do is they'll cut it, run it through and cut all four sides and give it an exact sizing. Can rectified tile have a calibration? Yes. And the reason is, as they keep running it through the saw, what happens to a saw blade? It gets smaller and smaller as the saw blade wears away, and the tile is creeping a little bit larger. So with a rectified tile, you still look for a calibrated sizes. It's going to be a lot more, it's going to be a lot closer in tolerance, but you are still going to have a calibration. The other thing with a rectified tile, what's interesting about the edge on it? Typically it's a square edge. So one of the things we have to be aware of is when we grout that, can't have a dip in the grout. Can't have your helper, as he washes out the grout, dip the grout. The joint is supposed to be flush and full. It's like installing quarry tile in a kitchen. Quarry tile in a kitchen, if you've ever noticed, is a square edge. There are no bevels on it. And your grout needs to fill that joint up completely. It's supposed to be flush. So when you roll a cart over it, no click, 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 doesn't collect dirt. Similarly with these rectified tiles, because they're square edge, the grout joint is supposed to be flush. So you get a smooth floor. That's the purpose of it. Advantage, or things to consider when you're looking at the porcelain. Of course, they're frost-proof, easy to maintain. They're a lot easier to keep clean, maintain. They're high flexural strength, stronger edges, better chemical resistance, definitely more resistant to wear and deep abrasion. Of course, the low absorption, as we mentioned, and they're intended for both interior, exterior, residential, commercial applications. And what we're seeing with the porcelains nowadays is the fact that how they're manufactured with all different finishes and textures and designs into them, making them look very unique and different, almost like natural stone. So as as the manufacturing has evolved with these porcelain tiles, I mean, porcelain has been around a long time. 1x1 mosaics, porcelain mosaics. And as we've started increasing in sizes, 12 by 12, that was the basis of design for years. And now they mentioned 2 foot by 4 foot panels are probably the most common panel we see, but we're also installing panels that are 4 foot by 10 foot panels, porcelain tile. So what's happening is that we're getting larger and larger with these. It poses different installation challenges as we move through it. Things to consider with it is the thickness, the flatness. The larger the tile, you got to remember, is that the tile is going to also have a crown to it in the firing process. So the more, the bigger the expanse, the more that you can have a crown in that tile. And so that's why you see that the TCNA doesn't recommend a true brick joint anymore with these larger tiles. Because if you have the low point at the edge meeting right at the middle point of the tile, which is the high point, it causes for a trip fall hazard, or it can. So consequently, we offset more when we're trying to install in a true brick pattern, but these rectangular porcelain tiles. So as we look at some of the installation challenges, substrate, surface conditions, wall, floor, ceiling, flatness, level, plumb, curvature, and deflection. We'll talk all about these. Flatness, is that the same as level? No. Okay, good. Flat means it's just the same pitch to it, whatever direction it is. There's no ups and downs in it. Level means, of course, just that. It's all the same height wherever you're going. Typically, the industry has called for years the flatness of your substrate being 1/4 of an inch in 10 feet. 1/4 of an inch in 10 feet. With these large formats, the flatness is now being called out to being 1/8 of an inch in 10 feet. Now, what do we know about that? The architect can design it. That's a given. The general contractor, the concrete guy, can say, yeah, I can pour it that way. That's a given. He's going to admit that he can do that. And the third thing we know is that it won't be poured that way. He just isn't going to hit those type of tolerances, especially 1/8 of an inch in 10 feet. So the first thing, as you guys get into these larger formats, the first thing is looking at that spec, and you know it's already called out. It should be called out 1/8 of an inch in 10 feet. And you're throwing your straight edge on there and levels on there or lasers, and you're going, whoa, we're way out. Before you ever get started, you're talking about to the architect, to the owner, to the end user, to the contractor, we got some issues here. We got some leveling to do. We got some bringing up of this floor or flattening out this floor so that I can install this tile, that the end user, the homeowner, or whoever it may be, is going to get an installation that they're expecting. A flat-looking floor, tighter joints, no lippage, everything running very smooth. So this holds true for both floors and the walls. Walls, it's also just as critical because of the washing of light down the walls. If you get that light too close and it's out, it's magnified tremendously, and it'll look like big gaps on the wall, and all it is the way that the lighting is hitting it. We're also going to talk about curvature and deflection. It's the movement in a slab or on a deck, how it's going up and down. Deflection also on the walls from wind loads if it's exterior, from thermal, and then we'll get into some talking about expansion too, from thermal expansion. Bonding the porcelain, mortar strength, mortar coverage, tile weight, and looking at the slippage, and if we're going to have problems with slippage. So as we look at deciding which mortar we're going to be using, the strength of the mortar. Are we looking for something with a high compressive strength because we know that there's going to be commercial trucks rolling over it? Or are we looking at something with some flexural strength because it might be on the second or third level of a mall with a lot of vibration? So being aware of that bag that you buy that you just tiled the mother-in-law's patio with is not going to work the same on the mall or the exterior of a facade of a building. Being aware of that, although all of them say, meets the requirements of ANSI 118.4, but being aware of the strength and what you expect the mortar to do. Coverage. What's the coverage on a tile installation? Interior tile installation, what's the coverage on your mortar? 85% interior, 85%, 95% exterior or wet areas. Now that means if I pick up a tile after you've put it down and I see ridges, what kind of coverage do you think I'm getting? Maybe 50%, maybe 50%. So it's very critical in order to, as we install these tiles, that we're making sure we're getting the right coverage. We're going to talk a little bit about the installation techniques in a little bit as we get into this a little further. Tile weight and slippage. If it's a heavier tile, you know, are we finding a mortar that will let it hang on the wall, that it won't allow it to slip down, won't allow it to slide? The quality is known as, here's the word of the day, thixotropic. Thixotropic. And what that is everybody knows, everybody's played with something that's thixotropic, and the example is Heinz 57 ketchup. Hold it over the tablecloth and hold it there all day and it'll never come out. Hit that bottle right on the number 57, you agitate it and it starts flowing. Okay, that works. Try it. It really does. It needs to be agitated to move, and that's what thixotropic means. The same as some of these mortars. You put them up, you put a heavy-weighted tile onto a wall, it won't slide, or onto a floor, it won't sink in. You agitate it, you can get it to sink in or slide or slip. But once you place it and you leave it alone, it's not slipping. So you do a large floor, heavier tile, you come in the next morning, and we've all seen this happen to us, where, some of them sink, and you got highs and lows, and now it's cured out and all the problems. Or on a wall, you're trying to shim it up, finding all kinds of spacers, keeping everything from slipping. A thixotropic mortar will help prevent those issues. Expansion and control joints, movement joints, thermal expansion. Talking about all of those. Are those our friends? Not really. Everybody hates working around them, but they are a necessity. And we have to address where they're going, how they're being used, and making sure that we're honoring them in the right place. Who's responsible for laying out the expansion joints on a job? The architect. It's his responsibility to lay out the expansion joints on the job. You as an installer should be working with him, but it is his responsibility to lay them out. It's not your responsibility. It's his responsibility. So we take a look at substrate surface condition. Fact 1, less projects in today's specifications include cost or height allowance for mortar beds or levelers. If anybody's been in the industry as long as I have, I'm sure some of you, everything was done with a mortar bed. You know, you either had a depressed slab or you were building it up. Today's building time, scope, weights of buildings, you just don't see it done anymore. And it's a dying art. With the ease and using of CVUs and the cost of floating walls or putting up mortar beds or render coats, it's that much less specified. So you're putting up your cement backer board and then bonding your tile directly to it. Substrates designed are more lightweight, more deformable, suspended slabs, wood trusses, all these things that we're going over. I mean, you take a look at some of the concrete spans that you're going over nowadays and the way that they've been able to reinforce concrete. You know, 36 foot of a concrete span, it's nothing, that isn't unheard of. You know, and years ago, you never would have seen it. So this deformability has an impact on your finished tile installation. Time constraints on every project. When was the last time you had the architect or the GC say, hey, don't worry, take an extra 4 or 5 weeks to get this job done? Yeah. As tile installers, we're getting called into the job at the very end of the job because it's finished work, and everybody else has run late. So now all of a sudden they're saying to you, well, can't you just throw in more crews and get this thing done on time? And nobody grasps the idea. You can't add more bodies in the room to making the job go faster. It just doesn't work. So, subsurface tolerances. We talked about this, the 1/4 inch and 10, now and a 1/16 of an inch and a foot, and now it's down to an 1/8 of an inch and 10 and a 1/16 of an inch and 2 feet. And then Fact 5, as I mentioned, that just doesn't fit into the GC's plans. You're not going to get it. Curvature. You know, it's the easiest way of explaining it is standing in a mall and on that second level, and all of a sudden you're feeling boom, 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 bouncing up and down. That's the curvature or the deflection of the mall. One of the interesting things, you can work with an architect and he'll say, I'm building this mall, okay, and we're going to do it with concrete. And great. And the designer picks out a beautiful stone or a large format tile. And great. Put it down onto the mall. Everything is wonderful. They've figured loads and all of these things. Then the mall owner tells you, oh, we're going to have a grand opening. We're going to park new cars all over this level, and we're going to march through probably 100,000 people this day. Now that mall is just bouncing up and down. One of the architectural classes I took years ago, one of the professors brought something up, and it's one of those pieces of useless information I keep in my head, but it's Roman soldiers, when they marched across a bridge, always broke stride. And the reason was because if you're in stride, you start this oscillating movement. It's like a wave pattern. And it would go racing out across the bridge, and when it comes back faster. So it would go faster and faster, and a bridge would collapse, could actually collapse. So they would break stride, so they wouldn't set up this wave pattern. Similarly, in a mall, when you're standing there and you're feeling that wave, it's going out, but it's coming in faster, and it keeps increasing in speed. And without the right mortars bonding this down, you're going to end up with a failure. You're going to end up, at some point, it is going to fail. You know, so when you're looking at a mall, a lot of times, you know, somebody might say, oh, you got to have a heavy compressive strength for the mortar. You may need deformable strength of the mortar to making it work for these upper levels of the malls. The effects of the curvature. On a small tile, you know, 6x6 up to a 6x6 tile, the slab is moving. You might get some grout cracking. More than likely, nothing. As you get into the larger format, if it's set tight, you're going to get grout cracking. You're going to get tiles chipping as they are getting pushed together up against one another. Definitely start having some problems, some delaminating, some breaking a bond. And then if we get into the really large patterns or a diagonal or a brick pattern, random effects, you got nothing but problems with a lot of deflection on that slab. So what are we looking at when we take a look at the mortars? In typical mortars, everybody's familiar with the specification, ANSI 118.4, 118.11, and now the new one, 118.15, which is a medium bed mortar, a true definition for medium bed. The other thing that we're seeing is that ANSI gives a definition of the product. It doesn't tell you what the product does. It gives you a definition of the product. A number of years ago, a number of the major manufacturers reached out and into the European community. Europe and a number of other countries have been using ISO standards for quite a few years. The ISO standards actually describe the physical properties of what the mortar or the grout or the mastic or the epoxy are actually going to do. So by using an ISO standard, what you're going to find out is that you can decide if this is, just by the nomenclature on it, if it's a deformable mortar, if it'll stick to plywood, if it's a modified mortar. And the nice thing about the ISO standards is that all of the manufacturers that have jumped in supporting this all use the same, it's exactly the same labeling, the same nomenclature, everything is set the same. It's an outside agency testing the products to making sure they meet those ISO standards. So look for that on the specifications. A lot of the major firms are now writing that into specifications along with the ANSI. It'll help you as a contractor. You got that 100,000 foot mall, and you know the right mortar that you should be installing with it, something with some deformability on it. And let's say that mortar you figured out it's going to cost you 75, 80 cents a square foot for the mortar. Reasonable price on it. 100,000 feet, some guy comes in and decides, I really want this job. I'm just going to bid it with the ANSI 118.4, the lowest common denominator out there. He's bidding out a mortar that might be costing him 15 cents a foot. All of a sudden you're leaving 65 cents a foot on the table, $65,000 on the table. You've been outbid. So what ISO does is by everybody bidding off of that, it levels the playing field for the contractor also, because now you know everybody's got to bid apples to apples with that product. Medium bed mortars. We'll talk a little bit about medium bed mortars. The idea of a medium bed mortar has been around for quite a while. However, there's never been one. Guys would concoct their own thing on the job site. I have to say I was guilty of that years ago too. Mixing up a little something extra to give it a little extra body, fill in some low areas with it. Should a thin set mortar be ever used for filling voids? Okay, good. I'm glad to hear that. The reason is a thin set mortar shrinks. And you've been called out to a job already where, perhaps you have, and where a bunch of tile has gone in maybe 6-8 months ago, and all of a sudden they rolled some heavy equipment through and tiles are breaking on the edges. And you open it up and you look and you go, where's the thin set? It's gone. And what's happened is it's pulled back. Thin set, as it cures, shrinks. You build it up too much and it shrinks even more. So a guy that's building up with thin set and then setting tile into that, he's going to end up with a problem. So if you're on a job and your installer says to you, or the contractor, you got a low spot over there, don't worry, I'll fill that up with a little bit of thin set. Throw him off the job, because he doesn't know what he's doing. He really doesn't know what he's doing. To filling up low areas and such, you need to be going in with the right type of patching material that's designed for that. Now, medium bed mortars, the purpose of them is that as we get into these larger tiles, they're heavier in some cases, or there's a little more deflection or curvature in the tiles. You're trying to get a body of mortar underneath that. So instead of concocting things into the field, the industry has actually looked at a definition of it, and that was just announced this year through ANSI 118.15. But it describes the use of the medium bed. You can build up a little bit more with a medium bed. With your traditional thin set, 3/16 of an inch is a maximum. With a medium bed, you can go up to 3/4 of an inch of mortar, and it'll support the weight. It won't sink. Again, you're not leveling the floor with this. You're not filling up big divots and holes with it. You're just taking care of that irregularity that might be in the tile, trying to get everything so it's nice and flat. Okay. We take a look at the floors. One of the things that I like to point out right away on this, it's a great installation of showing combing mortar in one direction. How many of you guys do that? How many have gone through a class and have learned about that? And the reason it's done is so that air can escape when you press the tile down into it. When you set your tile on top of it and you rock it back and forth across the ridges, it's breaking it down, getting full coverage. Try this sometime. Take a large piece of tile, swirl around the thin set mortar, plop it down. It's all swirled around. Try to beat it down into place. You can beat on that thing, go and lift it up and see what kind of coverage you have underneath. The air is holding it off from making actual coverage. So it's very critical, especially when you get into these bigger tiles, to comb in one direction. When you place that tile in there, you're moving it across the ridges, you break it down, and you're getting the coverage that's expected. As the owner of a shop and you got your installers out there working, come out there. Take a look at what they're doing. Hey, lift up that tile. Let me see what your coverage is. He doesn't have the right coverage, tell him just to keep on lifting until you see it. And then tell him, oh, by the way, that's all on you. You did it wrong. But you catch a guy one time, you show it to him one time, he doesn't make that mistake again. Critical part of it. Better contact between the large format porcelain tile and substrate. Reduce the hollow spots, voids underneath. Reduce the change of breaking the large format tile, the chances of it. Okay, to ensure the proper coverage, we talked a little bit about this. Select the right notch trowel to facilitate the coverage. Make sure that you're keying the mortar into the backside of the tile, the large tiles, doing it the right way. With the flat side of the trowel, keying it in, combing mortar onto it, combing in one direction. The direction both of how you're combing it onto the back of the tile and on the substrate go the same way. Lock it together. It becomes like a zipper action. Push it in, work it back and forth to making sure that it fills up. Proper depth of thin set. A lot of people always ask me, how do you know you got it properly, the right depth of it? It should come up, if you look inside the grout joint, it should come up 1/3 of the thickness of the tile up into the grout joint. That way you know you've got the right amount down in there. So the joint isn't stripped clean. It should come up about 1/3 of the height of the grout joint. And like they say, periodically remove tile to check and making sure that you're getting the proper coverage. And now we get into expansion joints. What do we know about them? That they're there. We hate going over them, working with them. They screw up the pattern, all of these things. Here's a quick question for you. First of all, 3 types of joints when we talk about movement joints: expansion joints, control joints, and saw cut joints. Those are the 3 types of joints. They all fall into this movement joint category. If you're doing a mall and you're on the 2nd story of this mall or an airport and you see the slabs and they've got a 3-inch gap or a 3-inch expansion joint in there between the 2 slabs, 3 inches there, and you come in to do the tile installation and they tell you the largest size grout joint we want to see is a 1/4 inch. What do you do about that 3-inch gap? Can you leave it as a 1/4 of an inch and put in a soft joint there? Will that work? No. The building is designed to move 3 inches. That's why that gap is there. Some engineer figured it out. It's going to push together that 3 inches. So if you've set tile over the top of it and left only a 1/4 of an inch, what's going to happen to your tile? It's exploding off the floor. It's coming right off. So those expansion joints, a true expansion joint, is designed in a building to let the building move both horizontally and vertically, up and down, together, pushing apart. It has to be completely honored. There's no ifs, ands, or buts about it. You've got to honor it, and whatever size it is, it's got to come all the way through your finished work. So that's why at airports you see those metal plates, or malls, you see those, because the joints are really wide, and it's the only way of making it look decent. Control joints. Control joints are used when they're pouring concrete. End of the day, want to stop pouring, just cut it off. Got the reinforcing metal still going through, they're coming back the next day, start pouring. That joint there's a cold joint. It will crack. We know that. Now, can we go over that joint? Yes, you can go over that joint properly prepared. Placing a soft joint, you have to have an slip sheet type membrane. That has to be the 1.5 times the width of the tile on either side of the joint. So if a tile is a foot wide, you're going to end up with 3 feet of material going over that joint. That way the tile is resting on the movement material, the crack isolation sheet. That's what you're trying to achieve. And you have to have a soft joint. It should be on both sides of that tile as it spans over that where that control joint is. This will work. We know that works. However, if that slab lifts, all bets are off. Okay? And that has to be pointed out to somebody. The best thing to do would be to honor that joint all the way through your finished work. Because if it does lift, you don't have a problem. But a lot of times because of layouts, designs, pattern work, it doesn't work. So you're looking at, okay, but making sure that the owner knows if the slabs lift, all bets are off. It's going to crack. You can't avoid that. Saw cut joints, why do we put them in? Why do we put in a saw cut joint? Because there's 2 things we know about concrete. There's cracked concrete and there's concrete that's gonna crack. So by putting in a saw joint or saw cut joint, we're trying to tell the concrete where we want it to crack, where we're gonna, so it doesn't run off all over. You see them coming off of columns typically, and in other areas, larger spans, they'll put it in because that's where they want the concrete to crack. Saw joint, saw cut joint, can we go over it? Yeah. Same procedure as a control joint. Okay, same procedure. More than likely you'll never get a heaving there, but you will get the lateral movement because that's what it's designed to do. Be familiar with the TCNA handbook. That's an old shot and on the movement joints. Here's a great job or picture of a job where no movement joints were put in. And the biggest thing that we have up there, this is where so many problems happen. You can eliminate so many problems by not grouting in tight up against the perimeter wall. For sure use soft material up around the perimeter. Okay, residential installations, I look at so many where I'll be called in, oh, we got a problem, come and take a look at this, and you see that the tile is buckled or cracked or whatever it may be, and you go around the perimeter, and it's all grouted in tight. And so we know what happens. The house is expanding and contracting. The walls are heating up and moving. It's pushing on that tile. If it's no place to go, if there's no soft joint somewhere, something's going to give. And either it'll delaminate or debond off the floor, or the tile will crack or pop up. So something will give. Perimeter joints are very critical, very crucial. And even, if residential work where you know you're going to run wood base over it, don't grout it in. Just set the wood base and cover it up. Make sure your layout is good so you don't have a gap there, but cover it up. Thermal expansion, this is a big, another thing to be aware of, is what happens when we're taking a look at the addressing movement joints, when we're looking at shrinkage and expansion because of changes of temperature. Normal expansion and shrinkage, we know that a building is constantly moving, and heat and cold will affect it. You'll have the continual dimensional movement due to these changes in the temperature. I grew up in Arizona, and a typical day in Tucson in the summer, you can have 120 in the shade, and surface temperature of a wall of tile, my gosh, it can be up to 180 degrees easily. All of a sudden they get those summer rains coming in there in the monsoons, and it's a cold rain that hits it, and there's this wham, there's this effect on the surface of that tile, and it's the movement. You use the wrong mortar, will it fail right away? No. Will it fail eventually? Absolutely. So it's very critical to be aware of the thermal expansion and movement when you're selecting the mortar for an exterior application like this. Thermal shock, the other things that can cause it, steam cleaning. They say the exterior tile, hot sun, cool rain. All of these different things. The expansion that can happen in a showroom where you got this large window of glass and all of a sudden the sun coming around, and it'll cook in the showroom more so than on the exterior of the building because the glass is acting as a magnifier to it also. So critical things to be aware of in movement. And it's just showing that little bit of movement. So you're looking at, again, on thermal expansion, or deformability, is the adhesive choice. Are we looking for something with compressive strength, or are we looking for something with deformability, something that'll move with it? Waterproofing and crack isolations, membranes are designed to help with that also, to absorb that movement, but you can also be picking it up with a thin-set mortar. And this, they just talk about the deformability and the classifications through ISO, how it's tested. And again, here we are spending a little bit of time talking about perimeter joints, making sure that they're not grouted in, that they're filled with a sealant, so that we don't have a failure at that area. So when we take a look at these large format porcelain tiles, and the key to the success of it, keys to a successful installation. Help the owner choose a high quality tile. Okay, if you're involved with that, make sure if the owner says I want a porcelain, that's what it is. Look at it, finding out. If it's something that has an unusual backing on it, ask that manufacturer, how has this tile been tested? What's been tested? What's going to stick to it? A good example, a number of years ago I was involved with a showroom in San Jose, car dealership. Contractor I knew really well from years ago, and he was using an agglomerate stone that had a mesh backing on it. Put it up with the right thin-set mortar, installed it all, everything was great. As the summer sun started coming around, hitting further into the window, the layout of this building, all of a sudden one day, what they had done is this stone was up on the wall 20 feet up in the showroom. And one day, all of a sudden, there was this crash, 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 and the tile was sliding down the wall. Well, I got the call that your mortar's not working. We've got a major failure. Get up here and figure this out. Up there right away, got up to the job, and there it was. My mortar was on the wall, and guess what was still on the wall with it? All of the mesh that was stuck onto the back of this agglomerate tile. Nobody had bothered to test how well this mesh was bonded to this tile. And when it got some heat on it and it started expanding and contracting, the glue wasn't good enough to hold it together. Fell off the wall. So what I'm making you think of as you look at these tiles that come into your desk as a contractor, and all of a sudden they say, this is what you're installing. We're getting this tile. And you look at the backing of it and you go, what is this? Ask them, what's been tested? How's it been tested? They don't know. Tell them to get it tested for you before you put your neck on the line in trying to install it, and then you're hooked. You're stuck. You start installing it, you own the job. So find out before you jump into those things. Consider if the substrate was designed for large format tile. If you're in this discussion with the general contractor, and I know that it's a shame we live in a society where low bid wins the job. It's a shame that we can't get into kind of an average bid. The closest to the average gets the job, because there'll be a lot less mistakes. But as you're negotiating with that contractor and telling him, hey, we're going to have to do some flattening, some leveling. We're using large format tile. You want this job to look right. We all want to get paid. Plan on the fact we're going to spend some money putting down a self-leveling underlayment or some sort of mortar bed to getting this floor flat, or some sort of patching or repairing to getting it done right. Plan on doing this surface prep. Put it into your bid. Put it in as a separate line item, letting the contractor know you're thinking about it. We may need to do this, and in case we do, here's what my number is. Here's what we're going to need. It doesn't come as a big surprise then. Use the right adhesive for the application. We talked today about thin-set mortars, ANSI 118.4, and without saying our company, our company alone, we have 25 products that comply with ANSI 118.4. 25 products, and my competition is just like that. So you as a contractor, listen to the people that are talking to you about these mortars. Test them, see where they're going to be working. Look at the differences between them. Don't, because I've used this particular one for all of these jobs, doesn't necessarily mean you were using the right one. That's what you need to be walking away from here today and thinking about. Coverage, coverage, coverage. Last question on that. Residential interior, what's the coverage? 85%. Commercial exterior wet areas, 95%. You can't get 100%. That was lost in court a couple of times. So you can't beat that one. And then following what the TCNA EJ 171 has to say about movement joints. All right, and holding to that. When you look at the cost of these specialized mortars and the systems that we're talking about, yeah, it adds a little more cost to your job. It does. And sometimes your labor might go up a little bit in working with some of these things and playing around, or you got to add some extra labor in there for the prep work. However, those costs there are very minimal compared to tearing out a job and having to do the whole thing over again for free. So look at that as where your ROI is. Where's your return on investment? What are you doing? Does it make sense to use this product? Are all of these high-end products always needed? Absolutely not. I'll be the first to tell you that. There are jobs when you can get by with a basic and it'll be fine. But think about the job you're doing. Think about the end product that you're trying to give that owner. Think about what kind of problems that we may be having in putting that installation together, so that you're not coming back in 4 months or 5 months and tearing out a floor, redoing it. So thank you. This concludes it. I open it up to questions or comments or anything else. We have a few minutes. Yes, sir. I spend quite a bit of time with the architects and the designers in this. The large format, just even talking about the backings on tiles. I tell the designers right away, you see that beautiful tile and you go, oh, that's what my owner wants. And you look at that backing, ask the next question. How can this be installed? What's going to be used? Because if they don't know, don't select it until you find out. Because there may be a whole bunch of hidden costs in there that, that we have to take into consideration. But yes, so the architects, the designers, the spec writers are being educated on this. I spend a lot of time with the spec writers because they're the ones being called. The architect says, here's the substrate, the building's going to be used for this. The designer said, here's the pretty tile and everything. The subcontractor, is trying to go, okay, how am I going to put this together? How am I going to get this job? Well, the spec writer, it's up to him to pull all of this together and making sure he's calling out the right mortars to giving it the right type of application. So spend a lot of time. Low bid with it, but that's why it's always good to put that as a separate item. The other thing that always gets me, and I was a subcontractor, I had my own company. Where do we get into the value engineering as a subcontractor? When it's listed out there, somebody has already done some research and figured out what products should be used. And especially when you get into the chemical makeups of some of these mortars now from whatever company. You know, you got guys that are getting paid hundreds of thousands of dollars. They have more initials after their names, their doctorates and all of this, designing these products to do these things. And then you or us as a subcontractor come in and go, let's do it this way. I can save some money there. That's not the place to be saving money. That's not the place to be saving money. Getting more organized on the job, how to get your guys more motivated to get it in and get it done right. That's where you save your money. Other questions? Wow. Yes, go ahead. Oh yeah, absolutely. It's easier to make, the compressive strengths that they're getting out of it. It's just, and we're not done yet on seeing how large this is going to go. It's just a matter of how big they can make a press. It's like I say, the largest I've worked with is 4 foot by 10 foot panels, and because of the durability of it, the looks that they can give with it. If you've ever been to one of the factories now, you'll see it start going through, and as they start putting down the screens, everything is turning. The stamps, little bits of turns, so you can go through hundreds of pieces and never find a duplicate. You know, because it's trying to give it that a stone look or a wood grain look or whatever it may be. Okay. Anything else? Yes, sir. Okay, yes, we can now talk non-proprietary, yes. There are a number of the manufacturers. MAPE does have facilities down in Florida and Montreal where we'll actually take the tile in there and do complete analysis on it, what will stick to it. Most of the time when you're seeing these resinous backings, you're looking at a two-part thin-set mortar is usually what will be recommended. So you're not just taking a multi-purpose, adding water into it, and let's go with it. You're looking at a two-part system. You're looking at things that end up a lot more flexible. And this is your polymers that go into a traditional mortar that's a multi-purpose. And you hold this in your hand for a bit, you'll feel that it'll warm up and you can move it. And then this is what's in a two-part system, the elasticity. You can play with these and pass them around if you want. I might have some more up here. Yeah. But you get an idea of the type of polymer that's used. And the real flexible one, as you play with this, the memory, it comes back. And that's why these two-part systems are used. You can pass it around, play with it, snap it off. Don't chew on it, okay, please? It gets back to, yeah, we see all of these resins on the back. And then the question is, who concocted it? What's on it? What's going to stick to it? And once it sticks to the resin, is there going to be such a pulling action that it makes the resin break off the back of the tile? And that's that job in San Jose that I talked about. The mortar just had the pulling action, and as soon as it got some heat on it where it expanded, it was down. So. Everybody stepped up to the plate on that one because nobody, I mean, everybody said, wow, we didn't think about testing it. And so the architect stepped up, the owner of the project stepped up, the contractor stepped up. So everybody took a bite and said, let's fix this, and we learned something. So. Oh yeah, the whole wall came down, scraped it down, and started all over. There was no way you were just going to patch this. Yeah. And I can't remember what car showroom it was, but just the tiles, the chances of it falling down and hitting a car, brand new car. You know, look at what that would cost. So, other questions? Yes, sir. Yeah, you're going to see it. The larger the tile, the more apt you are going to have for the crowning. Because as the tile, in the firing process of the tile, there's some shrinkage that goes on. And so as it shrinks, the longer it is, it's going to crown that way instead of the short way. Okay, you're not going to see it like this, but the length. So, pardon? You should pretty much count on it. Unless it gets into a thicker tile, it might not be as noticeable. But the thinner tiles, oh yeah, definitely. I would have to look up the actual standard on how it's classified as if it falls under ANSI A137.1 as a standard or a master spec tile, that it's meeting certain classifications, and there is a tolerance. It's a mathematical formula as the tile gets bigger how much it can be, and I don't have that memorized. Okay. Sorry on that, but you can't actually. TCNA handbook addresses it, ANSI addresses it. So either way, it'll bring it out. Absolutely, it's not into standards. How are you going to install it? What are you going to do? You know, that becomes a problem. Is the homeowner looking at something, wanting that curved? That isn't what they designed. Yes, sir. You're absolutely right. His question is, do we need to use two different types, a traditional thin set applied adhesive or a mortar, or the medium beds? If the job's calling out for medium bed, can we just use the same? Absolutely. Absolutely. On a larger job where some areas might not need it, it can be a cost savings. You know, you have to look at the job. Is it enough cost savings to have your guys screw up and put the wrong stuff in the wrong place? You know, that's, you determine that. But yeah, if it's medium bed, it can be used for, even a mosaic, and you can put in mosaic with it. Okay, good questions. Anything else? Wow. All right. Well, thank you very, very much. I appreciate the great attendance. Enjoy the show, and if you have any other questions, come by and see us at our booth, or grab me and ask me.